Chapter 10.1 and 10.2 is on parametric equations. Now, why parametric? What is useful about having a parametric equation? Well, let's take a look at what we knew before. What we knew before is something like x of t is equaling to t to the fourth minus 3t squared. What did this mean? This means really I only had one dimension of x, and depending on a certain point in time, I had some sort of particle moving back and forth. So at t equals 0, for example, I would be at 0. T equals 1, I would be somewhere negative. Somewhere it would move this way, then maybe move this way, move back and forth, right? Now after parametric, I now actually am defining two dimensions, an x of t and a y of t. So what that would now look like is now I have an x direction and I have a y direction / dimension. So now if I have some sort of particle or some sort of a little itty bitty ant, spider, I can track its path and where it's going. All right? So it's going somewhere this way, and it has some sort of a direction down this path of some sort. All right? Now, let's take a look at some examples of what a parametric equation could look like. Well, if I define the x parameter, the x of t, to be equal to t, and a y of t equal to t, what would the graph look like? Well, at any given point in time, my x and y are exactly the same, even when my time value is technically negative. So I have a graph that looks something like this. All right? Well, what if I have x of t equaling to t squared and y of t equaling to t squared? Now, when my t is negative, it looks like I don't actually get a negative output, negative x, negative y. So none of this would be in place. But this part would look exactly the same, where my output for x and my output for y would be exactly equal. So physically, the graph would look the same as this top part of x equaling t and y equaling t. But if at t equals 3 seconds, for example, my particle would be at 3,3. However, 3 seconds here, my particle will be at 9,9. So this one also seems to have some sort of speed, and it's going a lot faster than this one. Okay? Now, an example, this example. Let's take a look. I want to graph something that looks like this. X equals y to the fourth minus 3y squared. Now, in this case, if I were to do something like this on my graphing calculator, and I go to my y equals to, I have to get it in function form. I have to get the y by itself, which in this case is not possible. So what I'm going to do instead is I'm going to switch it over to parametric form. And the way I'm going to do that, in this case, x is going to be a function of t, so that because in this case, if x is equal to t to the fourth minus 3t squared, x would be some sort of a function. So I'm redefining my parameters to be this way if y is equal to t. So it's essentially just substitution. I'm making all the y's equal to t, and therefore x is equal to t to the fourth minus 3t squared. Now in your graphing calculator, what you have is if you go to mode and you go down to switch it over to parametric, and you look at your y equals, you can actually input your x parameter and your y parameter. So I inputted t to the fourth minus 3t squared here for x and t for y. Now when I hit graph, this is what it looks like. Right? It is not a function here, which is why we couldn't graph it in function form. Let's take a look at more specifics. Let's take a look at individually. Where is my particle at certain points in time? Well, at t equals 0, my particle is at 0, 0, 0, 0. At 1 second, right? You have 1 minus 3, which is negative 2. And then you have at 1 second positive 1. At t equals 2, you have your y is going to equal to 2, but this is going to equal to 16 minus 3 times 4. So that's going to equal to 4. At negative 1, so here we have 0, 0, 0, 0, negative 2, positive 1. So this is at t equals 0. This is at t equals 1. At t equals 2, it looks like it's shot all the way over here to 4, 2. So at t equals 2. So it's moving somewhat this way, as we already know from the graph that we saw. Right? And it definitely has some sort of a direction going this way. Well, let's look at the negative end. If there was negative time or going backwards, it's still going in this order from smallest to greatest. So at negative 1, at x equals negative 1, this becomes positive 1 minus 3. This is still negative 2, but this remains negative 1. This is negative 2, but this will become positive to give me positive 4. So I get positive 4, negative 2 at t equals negative 2. Negative 2, negative 1 at t equals negative 1, and then it goes back to 0.